Number 15, we've got a horizontal rod, and we've got a support here that is D from there. We've got a point here, E, which is the center of mass of the rod, and it's got mass M, so we'll put an mg here. We don't actually know how far that is there, do we? We've got another support here. Here to here is 2D. And it says, what does it say? A particle of mass M is placed on the end here. So we've got mg here. And I guess we're being asked to find, we're trying to find out where this is. So let's call that X, shall we? Call there to there X. This is support C, that is support D. So we're going to do moments about D. So taking that clockwise is this one here, which is mg times by the distance 2D minus this mg times by that distance there, which is x, and that of course will equal 0. So if I look, I've just got 2d mg equals mg x. The mg's cancel out, and so the distance there to there, x, is equal to 2d. Is that what we were asked? That wasn't what we were asked to find. We were actually asked to find there to there. But of course, the whole rod, it tells you, is 6d. So we've got 6d minus the 2d there, minus the x, equals the distance we want, A to E. And so we do have 2d as... It's a bit confusing. I got 2D there and the answer was 2D. Sorry about that. Part B, we've got the same system, but we've got to draw another diagram now. We've got the same mg going down here. And seeing as we knew that there to there was D, we now know there to there is D as well, don't we? We've then got this weight has been moved to the middle of the rod. So the middle of the rod is there. Then there's another D there. C, D, and that's 2D. Shall I go through that diagram? So this is what we had before, the center of mass at E, but we now knew it was here. We now knew that there to there was 2D. So I've got D and that D there. Look, that's enough. We're going to do moments about C this time. So looking around here, this one here, we've got mg times by D. This one here, we've got mg, and the distance there to there is 2D. And the force pushing up at this point here, going to call that one capital D at distance 3D. That will equal 0 because it's in equilibrium. So on this side here, I've got 3 capital D, little d. On this side over here, we've got 3g m d. Cancel the 3's, cancel the d's, and the force we're looking for, which you can just about see, is that the force will be mg.